record. And now I'm going to share my screen. Okay, so we can all see what I'm doing. All right, can you see my screen? Okay, yep. I'm gonna move it. I'm gonna see if it. Are you still with me, or did I lose you?
No, we're still.
Okay, because I moved it to another monitor. All right, here we go. You remember we go from we have to type in this DePaul-Porto.com. Remember that? So off to SPSS onto the server at DePaul. That's where I'm headed. That's why I have to do that. Here is what it looks like. It's asking me to go into the virtual lab. And I go. This takes a while. Remember, I told you we're doing big bandwidth stuff now. Okay. So it's going to take a minute.
I don't know if it's just my screen, but I see like a big blue line down the middle and like it's a black background.
Let me share again. Maybe there's some problem. How about now?
Okay.
You got it? Yeah. Sometimes it's just better to go out and come back. Okay. Yeah. To reset everything. And that's all I just did. All right. So here we are in the virtual lab. We're going to launch. So I'm literally at DePaul now. I'm on their server and now I'm pulling up their programs. Again, we're using a lot of computer power here. I mean, I've got you live. We're over on another server and I'm pulling up a big program. So this is pretty impressive in terms of technology. And I'm recording. All right, so here I am at DePaul, and here's the standard kind of desktop that you'll see when you go in. I set up ahead of time this virtual lab folder. So I'm going to pull that out. I also want to pull out just to show you, this is the program. So this is the program I'm going to use. Do not use this IBM SPSS modeler. They kind of look the same, but they're different. So we're going to go in, and this is what we have been using in every of the virtual lectures. So I'm going to go in and open up SPSS. This is version 26 that we're using. Okay, so remember it puts you into this screen, and if you wanted to go ahead and set up your data set, you could just click here, or, and exit, and then just go ahead and enter your data here. Okay, but I am actually set up a data set for today that I want to use. Under virtual lab. And I set this up. We are actually going to do a really important test today. I'm going to show you how to do regression modeling, which is what all of your papers are doing. So it'll be very helpful for your paper. It'll show you how to do the analysis for your paper. But I'm also going to use an example that's real, and that is we're going to test for salary discrimination, okay, through gender. And so this is a data set that SPSS has given us, and it's real data, and it looks at the, what determines your current salary. That's the research question here that we're going to look at today, okay? And so I'm going to show you how to do this first, but this is the actual output. So I'm going to save this, and I'm going to go in and actually pull up the data for that. Oh, this is sorry about that. I want to put this down. Sorry about that, guys. I don't want to show you the output before we actually do the data analysis. Okay, so this is what you would do. We're going to use a data set called employee data. This is what you would do. You would enter yours, and I'm going to use this sample here. And like I said, this is real data that SPSS gave us. All right, so they've already set up their variables, and they've set up in SPSS, they've set up the variable views. And so this is just what we've been learning. Here's the label, so you can see how everything is defined. Here are the values, so we can click in there and see what's missing. Okay, their values, how things were coded, and then declare the missing here. I have asked you to ignore these other columns because they're either aesthetics like alignment or not useful in the analysis and can be actually wrong here. All right, so here are the truncated titles of our variables, and here's what they mean. So we're going to take a look at what current salary, because we were looking for wage discrimination. Okay, we want to know what impacts, as a research question, your current salary. So current salary will be our dependent variable. You can see that it is interval. There are no codes. And so missing is 0. And you can see missing got declared 0. We don't want unemployed people, right? We want to look at what impacts your salary as our research question. Okay. Then that's going to, yeah.
Would you be able to just expand the window?
Oh, yes. I'm so sorry.
No worries.
Better?
Thank you so much. Yep.
Yeah, I am. I know I'm blind too, so it is very helpful. All right, so current salary is our dependent variable. The research question is, what impacts current salary? Now, in the example I want to do today, I want to write 3 hypotheses, just like you did in your paper. The first hypothesis is, in comparing people, the higher the education level, the higher the current salary. Seems reasonable. So we have education. Here is education. And education, notice, is interval. Okay, it's in number of years. It is not ordinal and it is not nominal. Okay, and so that's really important that you do not load ordinal data into this model. Into this particular analysis, your Y has to be interval. These were the requirements of your paper, by the way, from assignment 1 and 2. So the research hypothesis that we're testing is, in comparing people, the higher the greater the educational level, it is interval, the higher the current salary, which is also interval. Okay, you cannot use ordinal in this particular statistical program of analysis. All right, so we're going to do education, and we've determined education is indeed, they've got number of years. They didn't have to code this, obviously. Okay, they're starting above high school. All right, and so this is number of years. So we're good there. And we have a missing value here of 0, right? Because if you didn't, we want to get people that are above 12 and above in terms of their years. All right, the next hypothesis I want to look at is the months since hire, how long it has been that you've been on the job, because that has an impact on your current salary as well. And so months since hire, when you look here, months since hire is right there. And we know the number of months is indeed interval. And you can see that 0 is the only one, because you didn't need coding. The number of months is itself interval, but we want to make sure the person's employed. So we have 0 is missing. And you can see over here, 0 is missing. Okay. All right. And so the research hypothesis could be, in comparing people, the higher the month since hired, the greater the current salary. And then the last variable I want to take a look at as part of our regression analysis, as part of this modeling effort, is previous experience. And so previous experience is also in months. And so you can see previous experience, again, has 0 as missing. And so everything is interval there. And you can see they actually did not even declare a 0. So there must be, I suspect, no zeros in this data set for months of previous experience, which is good. All right, now look, we could have taken a look at minority classification, and today we are going to take a look at gender. And so we now have 3 research hypotheses, 1 independent variable, all three independent variables in those research hypotheses are interval. I just showed you that. Okay, and we're going to use a control of gender. Okay, gender should have no impact, right? If you have gender wage discrimination, then gender would have an impact. If females and males are paid the same, then we should see no significant impact of gender. That should be a variable that comes out as our control that is statistically insignificant. Everybody follow? Okay. Denise? Okay. All right. So we're going to use gender as a control. And you can see that here gender was actually designated as F and M. Okay. All right, now I went ahead and recoded this into numbers. So all the females got 0 and all the males got 1. So you should write that down. Okay, and remember that. All right, so this is how you use your variable view. It's really to teach yourself about the actual variables. Okay, find out what's missing, find out how are they measured, find out if indeed their interval, if it, you know, if they're the variables you want. Could we have used this variable? Let me show you this variable. What do you think about this variable? Is this nominal, ordinal, or interval? What do you guys think?
Nominal.
It's nominal. We could have used it. Okay, because remember the requirement for regression is the dependent variable has to be interval. 2 of the independent variables have to be interval. And then maybe a third variable could be nominal. So we could have done it by classification. Okay, but what it cannot be is ordinal. Ordinal can, that's a whole nother set of mathematics. So I just want to emphasize that for you. All right, let's take a look at the data view here. So this is where all the data is that we're going to actually analyze. And you can see that it's in inside of these columns, right? Just to repeat, what goes in the columns in a analysis? In a spreadsheet, what goes in the columns? In a data spreadsheet, what goes in the columns?
Sorry, in the SPSS
Yeah,
columns.
or
Oh,
Excel.
it's
It could have been Excel. It could any spreadsheet.
the independent variables.
Variables.
Oh,
Period. Variables. So it could be X, Y, and the control. Right? What goes in the rows in a data spreadsheet?
units of analysis.
Right. You're going to be asked this over and over again because this is how you have to know to set up your data spreadsheet. Columns here are variables. Rows are units of analysis. Okay, that there's no other options. Okay, because this is the mathematical matrix in which the computer will analyze. It includes Excel, any spreadsheet you work on. Okay. Okay. You guys got that? Okay. All right. So here's how you do. I'm going to show you your analysis, how to do the analysis, and then I'm going to exit and go over to our output. Because I've already highlighted it and done things to the output, so it's easier for you to identify what to read. But first, I want to show you how to operate SPSS so that you know how to do it for your paper as well. All right, so remember our friend analyze at the top, and then we had gone into in the past descriptive statistics and crosstabs, right? We're going to go past that and we're going to then go into regression. And we're going to do a simple linear regression. Note, and I talk about this in the lecture, there's weighted least squares. You can see that on there. 2-stage least. I mean, there's loads of different analyses using regression that you can do. We're going to keep it simple and go linear. Okay, so again, here's where all of our variables are, and it's asking you for the dependent variable. So what's our dependent variable here? Do you remember?
Current salary.
Correct, it's current salary.
Current salary.
Mm-hmm. 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 All right, and next it's asking here for our independent variables. And so those were the research questions that I generated. By the way, all of this is written down when we go over to D2L. So don't feel like you have to write all this down. I have it. We're going to jump over there in a second, okay?
Education level.
Education level.
Mm-hmm.
What else?
The you wrote down
Months since hire.
Since hired.
And then what's the last one, Denise?
The experience.
Correct. Correct. All right. And then what you would do, okay, is you would go ahead and put gender at the bottom because that's our control. It's not going to let us because I had to recode it. It's letters, but you would put gender right here, click there and put it in the bottom. Go over to statistics. Mm-hmm. And it's already set up for you. So make sure, because you're probably going into it for the first time, make sure that regression coefficient estimates is clicked and make sure the model fit is clicked. Remember in the lecture, we talked about the issues of problems with using regression. One of the assumptions is there is not a longitudinal problem, like a time series problem, right? And here's how you would test for time series problems at Durbin-Watson. That's talked about in the lecture briefly. But anyway, you just need this estimate and you need that model fit. And then you hit continue and you can go ahead and hit OK. All right. And so up comes this familiar index and the boxes. Okay. I want to stop here because I want to use the output that is already on D2L. Are there any questions about how to manage and get around SPSS and how to run your regression, how to set it up, run it? Any questions? It's pretty easy, isn't it? Again, it's just you analyze down to regression, over to linear, put in your variables, and don't forget to put in your control at the bottom. Okay, so all three independent variables go into the independent box as well as the control. Go to statistics, make sure you hit estimates and model fit. Okay? Questions? Because I'm going to leave this, I want to leave this area and go into interpreting the results. You guys good?
Okay.
Jillian? You good?
Yeah.
Okay. All right. I'm going to leave this. I think this is a really good recording for you to use when you're setting up your own data set for analysis. Okay. All right. I'm going to leave there now. And I'm going to share the results screen. Okay, here we go. Okay, you see the D2L? Everyone? Yeah, okay, good. All right, so here is in February 12th, the regression. This is our virtual lab for today. I'm going to show you the output and then I'm going to show you how to write the results here. So all of this information is located in this module, so feel free to listen and take notes to remind yourself, but you don't have to write everything down. I've already written it for you, okay? I think it just makes it easier for the student. All right, so here's what the output looks like where we just were on the server. So again, this is just the program codes if you were not in, if you had to program it yourself, if you were not in a Word, a Microsoft environment. Here's what the output looks like. So you're going to get the variables. These are all the variables that we entered. You can see I recoded gender, as I said. I had to turn it into 0 and 1. Months since previous higher education. These are all the variables that we entered. And it is telling you here. It's
Professor?
Yes.
We only see your Google screen.
Oh, okay. Hang on. I lost your, here you go. Now?
Yes.
Okay. Thanks for telling me, because it's what I see, right? I'm talking away. So here's the actual codes. I'll repeat. Here's the actual codes if we didn't have a, desktop version of SPSS. Here's what you would actually code, but we do. So it's pretty easy. Here's the printout. This is the variables we entered. You can see it's telling you recoded gender, which I did. I took females and coded them and males and coded them, right? You can't put the letter F or M into a spreadsheet and do analysis on it. It has to be a number that you coded. And with nominal data, which is gender, we have to code it. All right, and so here's our other X variables. You can see months since hire, previous experience, education levels, and it's telling you, okay, the dependent variable was current salary. So this is just telling you, and it's kind of a quality check. This is what you entered into SPSS. Make sure this is what you entered. All right, this is why I wanted to use this. I've highlighted the areas that you will read for interpretation, and we're going to talk about each of those right now. All right, so the first one that we're going to read is going to give us the strength of the model. Strength of the model. Third time, strength of the model. So this is called an adjusted R-square. You learned about it in the lecture. What this does is 3 R squares come out: a simple R, an R squared, and an adjusted R. And you can see that the one that we want to read is the adjusted R. Okay. The reason it's called adjusted is because it's adjusted for sample size and standard error. Okay. So we want to take a reasonable adjusted R squared to read it so that we are rather certain of the strength. The strength of this model, is it strong, medium, or weak?
Medium.
It's medium. It's moderate. Moderate strength, medium strength. Okay. The reason it's of the model is because we have 3 independent variables, not 1. Okay. So in the past, when we did chi-square and phi, and when we did Kendall's on ordinal, we only had 1 X and 1 Y. But now we have 3 X's. Okay. And a control. So we have to talk about the model first. We have to talk about the aggregate of the impact of these variables on Y. So the model is moderate. And I'm going to show you in the next section of the recording, when we get there, how to report that, but it's moderate. The other thing that we're going to look at is what's called analysis of variance. Okay. Analysis of variance basically determines, are these variables collectively actually statistically significant with Y? Is there statistical significant relationship collectively with Y? So we can't tell if one is statistically significant, X1, X2, or X3, or some combination. All we can say is, much like the adjusted R square that talks about the model, we can just say that this model collectively is statistically significant, because we're going to report the F statistic here. Sometimes it's called the global F statistic because it's reporting for the entire model. And we're going to report its significance. Now, how did I know this was statistically significant, this model? How did I know? How did you interpret this sig value?
It's less than 0.5. Yeah.
Point, you want to adjust that? 0.5? Is it 0.5?
0.05.
Yep. There you go. Okay, so statistical significance is the same that we've learned throughout. It does not change. Anything that is 0.05 or less is statistically significant. All right. Now, we can't see anything about F. Okay. It is not a correlation coefficient. It is not like Kendall's. It is not like phi. It doesn't range from +1 to 0 to -1. That's not what F is. But mathematically, do you remember from the lecture, what is F related to mathematically? Remember from the lecture? What other statistic did we not read as an index of -1, 0, +1? What other statistic did we not do that with? There was only one other. Think back.
Can you repeat what the question was? Sorry.
Sure. No. The F statistic is not read as a correlation coefficient. It is not read like +1 to 0 to -1. Remember that? Like we just read this. What other statistic do we not read on that scale of -1 to 0 to +1? There was one other statistic we did not read that way. There's only one. Chi-square. Chi-square. Chi-square, you just reported the number. You did not read the number. You only read the significance. So the F statistic is mathematically related to the chi-square calculation. Okay. All right. Let's take a look now. This is new. Okay, so now we've got a whole new set of coefficients I have to teach you to read. Notice just before I leave, again, SPSS tells you Y is the current salary. And again, it tells you all of the X's as well as the control that's in there. So it tells you everything that you put into the program. But now we're going to read it. Now, up until here, everything we've talked about in terms of adjusted R-square and the F statistic significance is about the model. When we get down to this particular area, we're going to go in after individual X's, and we're going to go into reading the control individually. Okay, so now we're at the individual level. Notice our good old friend statistical significance is still there. It's still read the same way. Notice things are positive and negative. Direction is read the same way. What is not here, and big asterisk, please. What is not here is strength. There is no way we can read at the individual level the strength of any of these individual X's or the gender control. Strength is only read for the model up here. That's it. Okay. Regression doesn't, these do not, nothing on this chart tells you the strength of the individual variables. All right. You're going to want to do that, by the way, when we start reading these. All right, let's start with our first X1 is educational level. Okay. Is there a statistically significant relationship between educational level and current salary? Yes or no?
Yes.
Right.
Yeah.
Right. Now, when we report the significance of this particular variable, we have to report, and you should only report, the standardized coefficient beta. This beta is always inflated over here, this B. The unstandardized coefficient is always inflated because it does not take into account sample size or the standard error. Okay, so we don't report the unstandardized beta or the standard error. What we report is the standard coefficient beta for educational level. Okay, So the sentence would read, when we report, we could say something like this. In comparing people, the higher, now where did I get higher from? How did I know it was higher education?
Because we said the greater the education.
That was our prediction though.
Yes.
What number, tell me what number you think is telling me direction here. How did I know it was greater?
The
That was-
5.
Yes,
Right.
go ahead, Denise. What about it? The 0.5, what about
The
it?
0.575 is more than half.
Well, it's positive, not negative.
Positive. Right. Yes.
I knew that's what you meant. So it's a positive number. So it's greater. You don't need any codes. This is interval data. So we can say in comparing people, the higher the education level, the higher the current salary. Remember with nominal and ordinal data, we had to code them. So there was an extra step in there. With interval data, it's a direct read. There's no codes with interval data. Kind of nice, huh? All right, so again, and this is written down for you, but I want to finish the sentence so you understand how to report it. In comparing people, the greater the educational level, the higher the current salary. Parent, standardized coefficient of beta equals 0.575, comma, sig period equals 0.000, close parent period.
Say that again.
I will, but don't forget, I do have it typed up for you. But that's sometimes writing it helps inculcate it too. So it's not bad to write it out either. In comparing people, the higher the educational level, comma, the greater the current salary. Parenthesis, standardized coefficient of beta equals 0.575, comma, sig period equals 0.000, close parent period. You have just now interpreted this individual value, individual independent variable of education and current salary. You didn't say anything. I'll repeat this again. You did not say anything about its strength. We just did. The only thing this tells you is significance and direction. Strength came from up here in the adjusted R-square. We can't say anything individually about strength. Okay? I repeat stuff because it's real tempting when you get this chart in front of you. It's going to be real tempting to do that. All right, next one. Yes or no? Is there any relationship between months since hire and current salary? Yes or no? No. Why not, Jillian?
You guys hear me?
Yep.
Okay, I'm using a new microphone, so I wasn't sure. But it's because the significance value is higher than 0.05, correct?
Correct. So let's write a sentence interpreting those results. In comparing people, remember, because people were our unit of analysis, so you know that's in every sentence pretty much. The month since hire has no statistical impact on current salary. Parentheses, standardized beta equals 0.041, comma, sig equals 0.217, close parenthesis period.
I have a quick question about just like writing, like in this type of writing, this is my first quantitative like research paper. Do you include like transitions? Like how does it actually look when it's like written in like a paragraph?
You know, yes, you do transitions. So I'm giving you like raw interpretation in a sentence.
Right, which is very helpful because I would never know how to write that. But
I know, right? And yes, you need material above it and material below it, and it needs to be in a paragraph and in a in the results section. Yeah.
okay, perfect.
Okay. But I'll tell you what, if you were like on the job, sitting and reporting to your supervisor these results, you do the sentence I just told you. Because otherwise, if you're not extremely direct and accurate, it'll be confusing, because the supervisor will be saying, well, is there a statistical significant relationship or not? Are these related or not? Because that's really the bottom line. And then if you say they're related, okay, how are they related and what's their strength? Okay, so real clean presentation language, real clean writing language. Okay. All right, let's go back through now and get the next one. Okay, previous years of experience. Did that X3 have any impact on current salary? No. No. Okay. All right, and then let's skip down to this last part. Now notice, let's go to the control now. Remember I said to you, the control was nominal. So I said to you that I coded female into 0 and male into 1. Okay. You have to know that with nominal ordinal data. You have to know what got coded. All right. So here's the recoded gender into nominal. Does gender impact our relationship between X and Y? Does the control matter? Yes or no?
Yes.
Correct. Jillian, how did you come up with that conclusion?
It's less than 0.05.
Right. There is a statistically significant relationship between men and women and their wage regarding this model. Now let's determine, that doesn't say anything, right? It doesn't tell me, it tells me the control has an impact, but it doesn't tell me who is getting paid more, which gender is getting paid more. Okay, so here this particular interpretation of the statistical significance just says overall the control has an impact. We have to go down and look at the standardized beta coefficient. Is it negative or positive? Positive. It's positive, right? So for the truffle, as I always say, who gets paid more in our data set?
Men.
Men,
Okay, Denise, how'd you determine that?
because it's 0.241.
And that's positive, right?
Positive, and their number was 1.
And what about the explain? Because it helps sometimes hearing your explanation from the students to another student.
It's great. It's greater than the 1 that females were paid 0, and male, we had 0 for female and 1 for male. Yeah. And it shows that the standardized coefficient beta is at 0.241.
Right. So because this is positive, it means the relationship in the coding, we have to go to the highest code. Males got the highest code. So who gets the highest pay because this is a positive correlation coefficient? Males.
Yeah.
This is, by the way, this is an actual test that can be used in courts and used by organizations for wage discrimination, minority discrimination. Okay. This is how you do it. Okay. All right, let's take a look now. I kind of walked you through. Now, before I leave this area, I want to show you, I went in and I highlighted the output for you. So you know exactly what to read and where to get it. Okay. You can ignore everything else. I want to talk about this value though, before I leave. Remember from the lecture, what's that value? The constant, right? What is the constant in linear regression? This is a tough question. Yes, it's the y-intercept. That's a tough question. Very good, Ray. Very good. So the constant is the y-intercept on a graph. So if I had a graph, it's right where it cuts our line, our linear regression line cuts the y-intercept. Another trick question. Is it a variable? No, it's a constant by definition. So there is no x1, x2, x3 with it. There is no data. It gets generated as a constant from our linear model. It is just the y-intercept. Here, notice it's negative. Okay. All right. Let me go now. Any questions before I leave here? Because I'm going to go now to the actual writing. I want to show you how to put it all together instead of just verbally telling you. But I wanted to walk you around this output. I think the highlights help, don't they? I think they help a lot. Okay. All right. I'm going to stop. I'm going to go now to, I want to go over now to the results section. Are you guys with me? You following? Please tell me. All right, I'm going to share this new screen. Okay, see my new screen? Okay, so I'm still in the module. Now this is what we looked at the raw output. This is now putting it all together in an equation and in writing sentences so that you can see that. This is the same thing we just did, just spelled out for you. The current salary was Y. Here's our 3 X's. Here's our control. Here's what the control was coded. Now, remember, we chose linear regression. Remember from the lecture, this is the actual equation for linear regression. It's the dependent variable equals A. What's A? What's A here? It's the constant. So A is that number we just saw. It was a negative 21703 off the data output. It is the constant. Plus B1. What's B in this equation? What's the name for B in this equation?
Isn't that the slope?
That's the slope. Good job, Casey. From the lecture, that's your slope. So it's the slope value, which we just read was 0.575, right? Okay. Times, literally, look, it's B1 times X1, literally. That's why these parentheses are around here. You multiply these two things. In this case, it's our variable education. Plus B2, and B2 was 0.041. It was insignificant though, remember? Times months since hire. Plus the slope for B3, which was 0.008. That was also insignificant. We had a 0.05 higher than 0.05 times previous experience. From the lecture, what's this little E sitting out here? What's that little E sitting out there?
A residual error.
Yeah. So whenever we put together these models, this is what business people do for forecasting. This is what we do as social scientists. Are there other things that describe current salary? Are there other X's out there that we did not include? Absolutely. Okay, so this is a literal term, the error value. Sometimes they're called residuals. Other things that are out there that impact Y, that are not included in X1, X2, X3. Also, if we ask the wrong question, if we get survey bias, if we have problems with validity or reliability, you've learned those concepts in this class and in other classes. Any errors in terms of reliability, validity, or variables that are not included in the equation get dumped into this error term. It's a source of error for us. Okay. All right. So then you took this very theoretical equation that just comes from being a linear regression. You added your X variables. And then now you, in an applied equation, you added the values as well. Okay. So now let's see if we can interpret this. First, about the model. Remember, there's only one place to get strength for the model. And remember, this is important because, right, months since hire was statistically insignificant, and so was experience. The only variable carrying this model is education. That was the only variable that was statistically significant. Okay. So about the model, here's what you can write. There is statistically significant. And remember, here's your F, comma, sig, and moderate. Remember, you told me that relationship. That's your strength between education, months since hire, and previous experience predicting the current salary of an employee. That's all you can say about the model. It's not until we go down into the standardized betas that we can determine which of these variables is actually the contributor to the model. Now about the independent variables. There is a statistically significant relationship between higher education and higher current salary. And this is what we said verbally. Here it is in writing. There is no statistical significant relationship between months since hire. Remember, it was 0.217, and previous experience. Remember, that was 0.030, 0.830. You guys with me? This is like what we just did orally. Now it's in writing. Okay. Next up, does gender matter? This is the test for gender discrimination in wage in current salary. And we determine, yes, gender does have an impact on current salary. There is salary discrimination in the sample. Now we report the results. See, this is like, I think, Bridget, you were saying, like, this is the normal language here, right? And then now you have to report the data, the results. There is a statistically significant relationship for males having higher salary. And then you report your standardized beta and your sig. Another way of saying this exact same thing, it's the exact same thing. There is a statistical relationship between females having lower current salary. You could have said this either way. They are logically the same sentence. Some reminders. Always look for significance first before interpreting strength or direction. If there's no statistical significance, you can't go to strength and direction on anything. There's no relationship. Okay. Model estimates are the F-sig is for the overall model. The adjusted R-square is for the overall strength. Then move to your standardized betas for significance and direction only. There is no strength in standardized betas. And look for controls. If there's no statistical significance, it means the control had no impact. If there is statistical significance, okay, then you do have to interpret that control and make a determination how that control had an impact. And you do that through the direction and the codes. Okay. Questions? I can go back over anything you want. Casey, tell me what you think.
I'm following, so I think I'm good.
Okay, Denise, I'm just calling you up the row here. Denise?
Oh, I think I have it. I can follow along. Yeah.
Okay. Bridget?
Get my numbers in.
I'm also good.
You're good. Ray? All right. Jillian?
Yeah, it makes sense now. I mean, I'm sure when I try and do it myself, I'm gonna come up.
Right. You're right.
I know. Well, and quite frankly, it's the same with the lectures. I can make things very clear for you. I can give you aids for them, but until you get in there and work with your own paper data, And that's why we do that. That's why we do that. Till you work with your own data. Okay. And that's why, guess what? Next Friday, we have another virtual lab. So you have time to work on your data and come to that lab with questions. There is one more thing we need to do. Okay. We're going to do that next week. Okay. In addition to the questions, there is one more test we're going to run. Okay. Remember in the lecture, we talked about the regression assumptions. There's a big section in the lecture about regression assumptions. Can you guys name some of those assumptions from the lecture?
X cannot be ordinal, can only be like nominal or interval.
Correct. What else?
No multicolon. I can't even remember how to pronounce it.
And the words get harder. Wait till we talk about homoskedicity, right? Heteroskedicity. All right, right. And that's what I was looking for. Next week, we're going to test for what's called multicollinearity. Okay, for the truffle. What is multicollinearity? Why is it important?
Does it have something to do with like understanding like X? That was all I could get. Was
Yeah,
like
yeah.
Understanding like why X was used or like what X means.
Mm-hmm. You're very much on top of it. Let me clarify it even closer for you. In social science, right? Say we're looking at the dependent variable of current salary. Lots of things impact your current salary. Lots of things impact if your dependent variable is crime rate. We only pick 3 things. Those 3 things can overlap. We're in the social world. So say you have independent variables of poverty, unemployment, right? These things overlap. Okay, homelessness. Okay, so it's not that these things are X alone, X1, X2, X3. In the social sciences, they overlap. Well, we have to be careful of that because we don't want so much overlap that we are masking the real relationship between X1 and X2 with Y. So we have to test for that. That's a source of error. We are going to test next week. Does anybody remember how we test from the lecture? How do we test for multicollinearity?
Was it Pearson's?
Correct. We're going to learn a new coefficient next week. I didn't want to add it on top of this week. But what it is a correlation coefficient. So we're going to run a test among our X's to see if they're related to each other. So we're going to eliminate Y and just run that +1, 0, -1 to see if there's any relation, any statistical strength to the relationship between the X's. We're hoping that there is not, but most likely there is. Okay, so we're going to do that next week. So bring your questions next week. That's a different test. And I'm going to show you how we're going to run a Pearson's R to check for multicollinearity. What are some other regression assumptions, please, from the lecture? I want to reinforce these. What else?
One of them was focused on parsimony, which is said was just like not having irrelevant X's.
Yes, parsimony. We want to only have X's that are relevant, that are not related to each other. We don't want to throw the kitchen sink in. What happens if you have too many X's, your adjusted R square goes up mathematically. It doesn't mean that you have a stronger model. It means you have more X's than you need sometimes. How do you know? It's called overdetermining. Here's what happens mathematically. Say you have a sample of 50, but you have maybe 12 X's. Of course, your adjusted R square is going to be very high, okay? Because you've overdetermined. You put too many X's into the equation. And mathematically, that drives up the adjusted R square. All right, so you don't want to have too many X's. You don't want to overdetermine the model. Okay, some more. What in the world is heteroskedicity? By the way, all these wonderful words you can use this weekend at your cocktail parties while you're inside with the snow and the cold. What is homo and heteroskedicity?
Error,
Error. Okay, Denise, what about it?
the terms that do not vary with the size of the elements.
Correct.
Dependent variable.
So we want, as part of this regression assumptions of what we need to run this model, do we want our error terms to vary? No, we want them to have the same variance. And so we want to have homoskedicity, the same variance. We don't want one variable to have such a high error rate and another one to be very low error. Okay. We want them to be equally in terms of their variances and their errors. So the error terms, we could do a graph in the lecture. There's a graph of the error terms. We want them to be the same. We do not want high error on one variable and low error on how we measured another variable. Okay. What about time series? What about our time series data? What's the problem with time series?
We need to, I think the issue comes with Y, or the dependent variable. It needs to lag, or you need to like, yeah, I guess, I think the example used was like with budgeting and just not having it be just directly based off of the last year.
Right. So let's talk, you're right. Let's talk about that. My public policy and my public administration students, when you work in the government or even in a nonprofit or private sector, actually, one year you start with a budget. How do you budget for the current year? What do they usually give you? What does management give you?
Last year's numbers.
Exactly. You don't work from zero, you work from last year's numbers. And so that means any errors, anything you did wrong last year shows up again this year. Okay. And so it isn't necessarily independent variables that are driving your particular budget. It's last year's budget, right? And you make incremental changes up or down to that budget. That means you have problems with what's called autocorrelation and longitudinal. It's longitudinal, okay, because it was based on another year. Okay. And so when you start working, when the dependent variable is budgets, sales, okay, the traditional one used is champagne sales. Are champagne sales based on the sales from last month? No, only if it's New Year's, right? They base it on the New Year's Eve sales from the year before. Okay, so that autocorrelation, I showed you, there's a Durbin-Watson statistic that SPSS calculates for you, and it will tell you, again, it's like, 0, 1, -1. It will tell you if you have autocorrelation. It looks at how the data is influenced by time. Okay, there's a way to correct for that, and that's what Ray was saying. You can take your dependent variable, last year's budget, and put it as an X and lag it from to last year. Okay, so say you get $10,000 last year in your budget. You budget for everything you're going to do last year. Maybe you'll do $1,000 more this year, 10% more. Okay, what predicts your budget this year? Last year's budget. Okay, so you take that $10,000 and you have to put it in your independent variables because that's the strongest predictor of what your budget is today. You only added an increment of $1,000. So that's why autocorrelation is a problem. When you start working with longitudinal data, and none of you are doing that, you are all doing cross-sectional data. One more thing on the two more things on the regression assumptions. They're obvious. The other one was linear. It's linear, right? My graduate students in this course had to take a look at nonlinear, right? So you took you took a look at it up in module 1, probe it and logit. Those are nonlinear. All right, so not everything in the world is linear. And when we do regression, we're assuming everything can be drawn by a line and that it's linear. Well, most of what we do is not linear. So that is a simplified place of assumption that we've made that could be an error. And random. And that's another thing that we usually violate, the random selection of data. We know that certain people don't answer questions based on income. Certain people don't answer questions based on religion. We know people over-report that they voted when they didn't vote. Okay. All right. So there's a lot of sources of error, and most of our data is who answers the question and if they answer it correctly to boot. All right. Questions. I want to challenge you with something. Are there any questions? Okay, hearing none, I want to challenge you with something. See this equation that we built here? This last area, y equals, see that? Correct, see that? Okay. What if I gave, what if a new employee walked in the door? And we have to determine what should the current salary be for this new employee? See this model right here that you built in SPSS? This is the equation to determine current salary of a new employee. So a new employee walks in, he or she gives us the number of months of previous experience. A new employee walks in, they give us the months since they were last hired. A new employee walks in, they give us their education level. I can put those numbers in here from that new employee, do the multiplication, do the addition, make sure I get my negative constant in that equation, and I can calculate what their current salary should be based on my organization. Pretty handy, huh? Pretty handy. Regression is a tool that is very handy in the workplace and in the courts, by the way. And all of you are doing it. All of you have your final paper. I've been moving you there section by section, are doing your own regression, your own model. That includes the forecasting as well as controlling for whatever you think needs to be controlled for. So all of you have a control, all of you have 3 X's, all of you have 1 Y, correct? Okay. Questions, guys?
I just have to head out for a meeting at 3, so I just
No, we should peel out too. We're only supposed to be on here till 3.
Thank you so much. Have a good weekend.
Bye, Bridget.
Bye.
All right, you guys, are you good? I'll stick around for questions, but I'm not teaching anything new from this point on. Next week.
I had a question. It's not really related to what we just learned, more about putting data in SPSS. I know you had told us how to create missing values, and I think I'm missing a step. So some of mine, like, it wasn't recorded, and so in the Excel sheet I have like n/a.
Oh yeah, you can't do that.
Yeah. I mean, I kind of figured that I messed up doing that.
That's okay. Take that n/a, which are characters and letters, right? Which are not numbers, and turn it into a -9.
Okay, yeah. Thank you.
All righty, guys. I'm going to click off. I'm going to compile this so that you can have it later. The other materials are already up that we used in the module from SPSS, as well as the writing, okay? All right, is anybody lost? Are you guys all good?
Okay. Yeah.
Okay. Are the virtual labs helping?
Yeah.
Very much.
Okay, good. Denise, is it making sense?
Making sense. I just have to figure out how to put my stuff in SPS and getting the sheets. Getting the numbers is what's bothering me right now. So.
Oh, getting the data. That's always the most stress. It's quite frankly, there's like two areas of stress. One is getting the data.
Yeah.
And the second one is like typing it in, getting it copied in and saving it. Those are, and they're mechanical. They're mechanical issues. All right. Go have a good weekend. Next week is our last virtual lab. So I would encourage you this week to work on your projects, bring your questions. And the only thing I'm doing next week then is, besides answering questions, is I'm going to show you how to test for multicollinearity using the Pearson's R. And that is a requirement in your paper. Okay. All right. Stay safe, my friends.
You too.
Take care, everyone.
Bye-bye.
Bye, guys. It's
Bye.
good seeing you all.